All right, this is an asynchronous assignment for March 22nd. We're going to do different types of error in hypothesis testing. So when we make decision in a real world, there's variation always exists. There's always a possibility of making a mistake. We can't get away from error. To explain the mistakes, we can think back to the analogy of a criminal trial. Our null, our assumption is of innocence, and then our alternative, what we're trying to prove is that they're guilty. Our verdict can go one of two ways. Either the person is found guilty, we go beyond that reasonable doubt, less than alpha, or if they're found not guilty. And we always say there's not enough evidence to establish guilt. We never say they're innocent. Beyond their verdict, there's actually some sort of truth beyond there. We may not know it at the time of the trial. Sometimes it comes out later, sometimes many, many years later. But there is a real truth. Either the person is guilty or they're innocent. And that happens for both of those decision-making trees. If they're found guilty and then it turns out they really are guilty, we've made a correct decision. If they are found not guilty and they really were innocent, that is also a correct decision. But there are also two incorrect decisions. I could get a guilty verdict, but the person is actually innocent. We have an innocent person that's been convicted. Another option is that a person is found not guilty, but in fact, they really did commit the crime, and we have a guilty person that is let free. Those are our two error methods. This table sort of summarizes it, and we have our two types of error we're going to be talking about. Someone is found guilty, but in actuality, they're innocent. So our type 1 error is our what we have is we have the innocent person who has been convicted. And then our type 2 error is the error where we have a guilty person that goes free. In our legal system, type 1 error is typically considered the more serious of the errors. And the errors, they have sort of a relationship that as one goes up, the other goes down. We can never get rid of them both, and we have to sort of have a balance, because as you raise one, the other goes down. As if you know you want the other to go down, it raises the other. So here's the same decision tree for our hypothesis test. It's similar but different language. Here we have our decision, and we either reject or fail to reject. And the truth beyond there, either the null really is false and we should have rejected, or the null is true. If we reject, and in fact that the null was false, we made a correct decision. If we fail to reject, and the null is true, right, that's another correct decision. And then our two errors are, if we reject and we shouldn't have, the null is really true, we get a type 1 error. If we fail to reject and the null is really false, we get a type 2 error. And here's that same grid. There's one other word here. When we reject the null and we really should have, that's called the power of the test. Okay, so here's a summary of type 1 error. We reject the null hypothesis when it is actually true. This is usually regarded as the more serious type of error. In our legal system analogy, this is an innocent person going to jail. We usually kind of err, we try to keep this as low as possible. In a medical context, it could mean that changing to a new treatment when the older treatment is actually better. We get to choose the amount of type 1 error we are willing to tolerate. The probability of committing a type 1 error is equal to the significance level. I can actually write that in symbols. The probability of type 1 error is actually equal to alpha. So we pick this one, and the lower my alpha, the higher the probability of making a type 2 error. The higher the alpha, the lower the probability of making our type 2 error. So I do have to kind of balance that out. Our type 2 errors, we fail to reject the null hypothesis when it is actually false. In our legal system analogy, this is that guilty person going free. This is also not a good scenario. It's usually not considered as bad, but again, it's still a matter of balance. In a medical context, this would mean keeping a standard treatment when the newer treatment is actually better. And to calculate this, we would actually need to know the value of the true parameter, which we usually don't, and we won't be calculating this in this course. Power, I mentioned that word. Power is the probability of correctly rejecting the null hypothesis when it is when it's actually false. It's like making this right decision, of going with the alternative when that's the right decision. It's actually the complement of making a type 2 error. Those two things add to one. We won't calculate this value in class, but a few ways to increase the power of a test are a good thing to know. So how to increase your power? You can take a bigger sample, which actually reduces the standard deviation of my sampling distribution. So I get basically a better test, a more accurate test. The other way I can do it is to increase my type 1 error. But I have to be careful here because while it will help me reject my own null hypothesis, I'll reject it more often. That means I'll also be committing this error, which can be a bad thing. So I need to make sure it's a sort of a balanced situation. We're going to look at one example, and I'm going to read this context and then we'll break it down. So slow response times by paramedics, firefighters, police officers can have serious consequences for accident victims. In the case of life-threatening injuries, victims generally need medical attention within 8 minutes of the accident. Several cities began monitoring emergency response times. They found emergency personnel arrived within 8 minutes after 78% of all calls involving life-threatening injuries last year. In the new year, the city manager started a Do Better initiative. During the year, the city manager wants to check the progress and selects a simple random sample of 400 calls involving life-threatening injuries and examines their response times. The city manager was looking for evidence that the proportion of calls where emergency responders were there within 8 minutes has increased. Okay, so let's break down the prompt. I see the 78%. This is my null hypothesis. This is my HO. 400, this is my N. I've got N equals 400. This right here, down at the bottom of my prompt, I see proportion of calls where emergency responders were there within 8 minutes. I see that this really is my parameter. This is my what I'm looking for, and it's a proportion. P equals the proportion of calls where emergency responders were there within 8 minutes. And then this word increased is important. It tells me the direction of my test. It tells me my alternative, which is that P is greater than 0.78. Okay, let's go ahead and answer a few questions about this. So defining the parameter of interest, that's easy enough. We had found that in the prompt. P is the proportion of calls where emergency responders were there within 8 minutes. Looking towards the bottom of a prompt is always a great place to look for that parameter. My null hypothesis, right? They had this comparison number. The null is that it's equal to that 0.78. That last word of the prompt here tells me that my alternative is I want it to be greater. The city manager is trying to prove that percentage. Now we're going to look at type 1 and type 2 error in this describing the type 1 and type 2 error and describing a consequence in this situation. So first, we'll look at sort of just summarizing what is type 1 error. Type 1 is when we reject the null when it's true. So there's just that fact. In this context, what that would mean is that they're looking for this increase. That means that they find the evidence that the proportion has increased when in actuality it hasn't. The consequence for this is if they think it's doing better when it actually hasn't, maybe they don't work or spend more money to make the response better when maybe they should. And that could result in more people dying, right? If they're not improving this number, that means that more people could be dying, which is a pretty serious consequence. Let's go ahead and break down type 2 error. Now, type 2 is failed to reject when it's false, when I really should. What this means is they don't find evidence, right? They don't find an evidence of an increase when it actually has. And what could this mean as a consequence? Well, maybe they work harder to try to increase this percentage when in actuality they already did that. In this case, they'd be spending more money, which is a downside, but they would be saving more lives. And so hopefully this has helped some with type 1 and type 2 error. Come to office hours this week if you have more questions. Take care, and if I don't see you, have a wonderful spring break, and I look forward to seeing you all when we get back.